Let me put you in the room. You are in the system design interview. The interviewer leans back and say six casual words. Design YouTube for me or Instagram or a ride sharing app. Then they go quiet and your mind goes blank. There is a whiteboard, there is a marker in your hand, and there is this awful silence where you are supposed to be brilliant. So you panic. You start drawing boxes. A box for app, a box for database, an arrow between them. You are talking fast, jumping around, throwing out words like microservices, load balancer, hoping something sticks. 10 minutes in, you have got a messy diagram, no real plan, an interviewer who is slowly losing interest. Here is the painful truth about why this happens. Most people prepare for coding interviews by grinding hundreds of problems, but system design isn't like that. There is no single right answer to memorize. A question is wide open, and without a plan, a walk through it, even a brilliant engineer freeze, ramble, and run out of time. So the problem isn't that you don't know enough about databases or caching. The problem is you don't have a path through the question. You are trying to build something huge with no method. Good news, there is a method, and once you have it, that terrifying one question turns into calm, step-by-step conversation. So let's get into it. Here's the one shift that fixes almost everything. Stop thinking of yourself as a bricklayer and start thinking of yourself as an architect. Imagine someone walks up to the architect and says, "Build me a house." A bad, panicky builder grabs bricks and starts stacking a wall immediately. A real architect doesn't touch a single brick. First, they ask questions. How many people will live here? What's the budget? Do you need garage? Only then do they sketch a blueprint, and only after that do they worry about plumbing and wiring. That's the entire secret. A system design interview is not a test of how fast you can lay bricks. It's a test of whether you can think like an architect. Ask the right questions, draw a sensible blueprint, and make smart trade-offs out loud. Hold that picture. The architect who asks before they build. For the rest of this video, everything else is just the step an architect follows. What the interview is actually testing. This matters because most people are answering the wrong exam. The interviewer does not expect you to design a perfect real-world YouTube in 40 minutes. Real companies have hundreds of engineers and years to do that. So what are they really watching for? Three things. 1. How you think. Do you break a huge scary problem into smaller calm pieces? 2. Your trade-offs. Every choice in a design has a cost. Do you know why you will pick one option over another, and can you say it out loud? 3. How you communicate. Can you drive the conversation, explain your thinking, and work with the interviewer instead of going silent? Notice what's not on that list. Knowing the one true answer. There isn't one. A senior engineer and a junior can design the same system completely differently and both be right, as long as they can defend their choices. So your job isn't to be perfect, it's to think clearly out loud like an architect. The 5-step framework. This is the heart of it. Here are the 5 steps that turn any design X for me question into calm, structure walk. Memorize these 5 and you will never freeze again. Step 1. Clarify the requirement. Ask before you build. Do not draw anything yet. First ask question, just like the architect asking about the house. Split it into 2 kinds. Functional requirement are the features. What must the system actually do? For design Twitter, that might be post a tweet, follow people, see a feed, pin down the 2 or 3 core features and ignore the rest, or you will be drowned. Non-functional requirements are the qualities. How must it behave? How many users? How fast does it need to be? Can it ever go down? Is it okay if data is few seconds out of date? This step alone separates the seniors from the juniors. The juniors start drawing. The senior asks, how many users are we designing for? Because the answer changes everything that follows. Step 2 is estimate the scale. Back of the envelope math. Now do some rough numbers out loud. How many users a day? How many reads versus writes per second? Roughly how much storage in a year? You are not aiming for exact figures. You are figuring out the size of the problem. Designing for 1,000 users and designing for 1 billion are completely different building. This is how you justify your later choices. We have 100 times more reads than writes, so I will add a cache. That single sentence makes you sound like you have done this before. Step 3. Define the interface and the data. Quickly sketch the main actions the system offers, the interface or the APIs for Twitter, post tweet, get feed, follow user, just the names and what goes in and out. Then ask, what are we actually storing? Users, tweets, follows. This is your data model. You don't need every detail, just enough to show you know what information lives where. This is the architect listing the rooms before drawing walls. Step 4. Draw the high level design, the blueprint. Now you draw the boxes, but calmly and in a sensible order. A typical picture flows like this. The user's phone talks to a load balancer, which spreads requests across several servers, which reads and writes to the database. Then you add the helpers your earlier number justified, a cache in front of database for speed, a content delivery network for images and videos, a message queue for work that can happen in the background. Keep it clean and high level. You are showing the floor plan, not every nail and every box you add. You explain why it's there, pointing back to a requirement from step 1 or a number from step 2. Step 5. Go deep and handle the bottlenecks, plumbing, wiring and earthquake. This is where you earn the senior rating. Pick the trickiest part of your design and go deeper and ask the architect hard question. What breaks when this gets huge? What happens when one database can't handle all the reads? Add read copies or split the data across machine. That's sharding. What if server dies? Is there a backup or does the whole thing go down? What's the slowest part? How do you speed it up? Here you talk about the real trade-offs. Faster but more complex, cheaper but slower, always correct versus always available. You won't solve everything and that's fine. Showing you can spot the weak points and reason about fixes is the whole game. 5 steps: clarify, estimate, define, draw, deep dive. That's your path through any question. Let's use it. A 60-second example. Let's make it real. Imagine they say design a link shortener, something that turns a long web address into a tiny one. First, clarify. Core feature. Paste long link, get a short one back. Clicking the short one sends you to the long one. Non-functional. Way more people click short link and then create them. So it's very read heavy and it must be fast and always up. Then estimate, maybe 100 reads for every one write. That's a read heavy fact. Is a gift. It screams cache. Then interface and data. 2 actions. Create short link and go to long link. We store a simple pairing, the short code and the long link it points to. Draw. Phone to a load balancer, to a few server, to a database holding those pairings, plus a cache in front because we said it's a read heavy. Then go deep. How do we make the short codes unique so 2 links never collide? How does the cache help us serve millions of clicks without hammering the database? See what happened. A scary blank question become a 5-minute confident conversation. Same framework every single time. So what are the common mistakes? Drawing before asking. This is a number 1 killer. You start stacking brick before you know what house you are building. Always spend the first couple of minutes on requirement. Second mistake is trying to design everything. You can't build all the YouTube in the 40 minutes. Pick the 2 or 3 core features. Go deep in those. Trying to cover it all means covering nothing well. Naming things before reasons. Saying I will add Kafka and Redis and microservices without explaining why is a red flag. One component you can justify beats 5 you just named dropped. Fourth, going silent. The interviewer can't read your mind. A long quiet pause while you think looks like you are stuck. Think out loud. They are grading the conversation, not just the diagram. Next is forgetting the trade-offs. Every choice has a cost. If you never mention a downside, it looks like you don't know there is one. Saying this is faster but uses more memory instantly makes you sound senior. The question you will actually get in the interview. These prompts comes up again and again, and now you have a path for everyone. Design a URL shortener, the classic starter, perfect for practicing the full framework end to end. Then design Twitter, Instagram, a news feed. This tests how you handle read heavy system and the famous feed problem. Then design a chat app like WhatsApp. Test real-time messaging and delivery. Design YouTube and Netflix. Test a storage, streaming and content delivery at huge scale. Design Uber. Test location matching and real-time updates. For every one of them, your move is same. Don't panic, don't draw at. Smile and say, great, let me start by clarifying few requirements. That one sentence by you calm and signal you have done this before. So quick recap, 3 things to carry into the room. A system design interview has no single right answer. Follow the 5 steps every time. The biggest difference between junior and senior is the first 2 minutes. A senior asks questions before drawing a single box. So that's all about this session. If you want to learn system design, I am running a end-to-end playlist that will definitely help you. Follow this channel for more such content.